Hey there, Aunt Leah. Okay, so I want to go a little bit over, excuse me, some of my notes about binary systems and really how things work. So first, I wanted to kind of talk about this area here with the base 10 system. Because in order to understand binary, we have to understand our bases. So let's see. So what we really have here is that so we take any number, right? Whatever number you want. Let's deal with 256, right? So 256 is really just 200 plus 50, excuse me, plus 6. And we can see that, right? 50 plus 6 is 56, and then 200 plus 56 is 256. So that makes sense. But that's just shorthand for writing all of this. And then we can think about each of these terms, right? So 200 we can look at in terms of groups. It tells me that I have two groups of 100, right? So we'll talk about groups that way. And I have 5 groups of 10. And I have 6 groups of 1. So if I add up the total amount of every item I have, right? So I have 100 items, but I have 2 groups there. So there's 200. Excuse me. And I have 5 groups of 10 items, and I have 6 groups of 1 item. So I have 6 individuals, and 50 groups of 10 or in blocks of 10, and then I have 200 in blocks of 100 total items. So all told, I have 256 items. So that's kind of where this comes from. And we can look at each of these terms in 1, 10, and 100 in terms of the exponents. And this is what we mean by base. So a base of some power, right? Let me increase my document here so that I have, say, I don't know, I'll call it B. And then if I have some exponent, I'll call it 2, right? So we'll just do B squared. In this case, B is the base and 2 is the exponent. Right? So I have bases and exponents. An exponent tells me that in this case, I have how many times am I going to multiply B by itself? So B2, or 2 of them, so B times B is equal to B squared. Right, whatever my base happens to be. In the case of a base 10 system, if I have 10 squared, that's telling me that I have 2 10s that I'm multiplying together. So 10 times 10. And 10 times 10 is 100. And really the shortcut to looking at base 10 numbers is that whatever the exponent is how many zeros come after the 1. So 10 to the 4th is going to have a 1 and then 4 zeros. 10 cubed will have 3 zeros. Or excuse me, whoops, I messed that one up. 4 zeros there. Three zeros. And then kind of so on. So we can rewrite each of these numbers over here in terms of its base and exponents. So these are all going to be in a base 10 system. These are all powers of 10. And then remember that any number to the 0 power is going to be 1. So kind of go by the number of zeros rule that I mentioned. 10 to the 0 has has no zeros after the 1. But that works with everything. So whatever your base is. So 3 to the 0 is also 1. Right? Whatever number you have is always 1 if it's to the 0 power. So here we'd have this guy. 100 we can write as 10 squared. 10 is 10 to the 1st, which is I'm multiplying 10 times one of them. So I only have 1 10 that I'm multiplying. So there's really nothing to multiply. and then this one down here is 10 to the 0. So then I have 2 times 10 squared. I have 5 times 10 to the first, and then I have 6 times 10 to the 0. So this is how our current number system works, the ones everybody's familiar with. When you count to 9, think about the ones place. When you have 9, if you add 1 to it, what happens to the ones place? It goes back to 0. It starts over. But you get another number in front of it. We add 1 to the next column. And if you think about it in terms of these columns, right, so we'll kind of box this off here. And this is pretty poor. But when you're writing these tables out, the first column, second column, third column, so on, each column is going to refer to different powers of 10. So this first one here would be, how many 10 to the 0 do you have? So if I only have 9, then I have 9 10 to the 0s, which is 1. I have 9 ones. But if I add 1 to it, then I go back to 0. I have 0 ones in my ones place, but I have 1 in my tens place. And 10, this is 10 to the first column, and this is the 10 to the second column. So for the number 9, I have 0. 10 squareds are 100, and I have 0 tens. But when I add 1 to that, then I have 0 ones, but I have 1 10. So it moves to the next column, and this goes back to 0. And the same thing will happen in the binary system. So let's consider the binary system now. So if we had, the binary system works in the same manner, right? It just tells you that for any number, right, and we'll look at some number, we'll call it, the binary system is only going to work in ones and zeros. And I'll explain why here in a second. And it's the same principle as in the base 10 system, only goes from 0 to 9. At some point you reach the cap, and it's going to add 1 to the next column. Because once I have 9, if I add 1 to it, then I have 10, which can be written as 10 to the first, instead of, I'm not going to have 10 ones, which is a way to explain it. But when I break it into these tables, I can just simplify that to 1 times 10, as opposed to 10 times 10 to the 0. So it's about the largest amount that'll fit in the column without going to the next one. So let's say that this column here is our 2 to the 0. This will be 2 to the first. This will be 2 cubed, 2 to the fourth, 2 to the fifth, and 2 to the sixth. Now, if we were to compute these, let's get in here. So really we can think of this column as ones. When we talk about the base 10 system, this becomes 2s, 4s. These are how many 4 I have. And then we can, later this will come into the conversion back. 4 times 2 is 8, 16, and 32. So this number down here tells me that I have, we start from the right and work backwards. It tells me that I have 1, 2 to the 0, I have 0, 2 to the first, I have 1, 2 to the third, I have 0, 2 to the fourth, and I have 1, 2 to the fifth, but I have zeros everything else. So if I were given this number down here and told to convert it to a base 10, I'm going to put it in a table like this. And this tells me how many of each I have. So I have here a 1, 2 to the first. So I'm going to take and just make a table of what I have. I have 1, 2 to the first, or 2 to the 0, excuse me. 1 times 2 to the 0. I have 1 times 2 to the third, and I have 1 times 2 to the fifth. So then if I add these, like work these out mathematically, 1 times 2 to the 0, 2 to the 0 is 1, so 1 times 1 is 1. 2 to the 2 cubed is 8, so I have 1 times 8, which is 8. And then 2 to the fifth, wait a minute, I screwed something up somewhere. 2, 1, 4. Ah, I screwed this up. I forgot 2 squared. Okay, let's erase these guys. See? I'm really good at math and I still made an error. Okay, let's try that again. So, 2 to the zeros. Ooh, that's a big marker. 2 to the first. 2 squared. 2 cubed. 2 to the fourth. And 2 to the fifth. Okay, so, right, 1, 2, 3, 4, 5. Okay, better. So this one, this column here is 1. This column is 2. This column is 4. This column is 8. This column is 16. And this column is 32. Okay, so now back to what I had before. I have 1, 2 to the 0, ooh, times 9, 2 to the 0, which equals 1, times 1, which equals 1. Then I have 1 times 2 squared, which equals 1 times 4, which equals 4. And then I have 1 times 2 to the fourth, which equals 1 times 16, which equals 16. And now I can add all those numbers. 1 plus 4 plus 16 is 21. So this number, written in base 10, is 21. And that's how we converted it. So the same can be done in any direction, no matter what your base is. If I give you a base, if I give you 21, say convert that to binary, I'm going to write this out. I'm going to go through the division method like I mentioned before. I'm going to divide out powers of 2 starting with the highest ones and then take each piece. Now this video has only allowed me to do 15 minutes, so it's going to run out of time here, so I'll make another one about how to go back here in just a second. But I hope this part makes sense.